All right, this is section 4.4 and 4.5 together, where we're going to be talking about perpendicular lines and the equations of parallel and perpendicular lines. The learning target for this lesson is I can use the perpendicular bisector theorem, and I can determine and write the equations of parallel and perpendicular lines. So the first thing we're going to look at is the perpendicular bisector theorem, which states that if a point is on the perpendicular bisector of a segment, then it is equidistant from the endpoints of the segment. So think about what this is saying here. Perpendicular bisector, right? Bisector means that it splits the segment in two equal parts, right? In half. And perpendicular is that it cuts in a right and it forms a right angle, right? An angle of 90 degrees. Okay, so perpendicular bisector. Um, let's look at this first problem here. I am going to go over one of them with you, and then you're going to do the second one on your own. Use the diagram shown, and then it's telling us that BD is the perpendicular bisector of AC. So BD is the perpendicular bisector of AC. Okay, so we know this angle here is 90, and we know that this splits the segment in half. So AE is congruent to EC. Okay. So it's asking us if we know that ED is 16, so ED is 16, and DA is 20, right? Find DC. So because BD is the perpendicular bisector of AC, okay? So we know that it splits it in half right here. So then DA has to be equal to DC, okay? And since DA is 20 centimeters, we know that DC is also 20 centimeters. Okay? Now I would like for you to do the next problem on your own. The next part is the converse of the perpendicular bisector theorem. I just would like to make a connection with the converses that we've seen recently of the parallel lines, those angle pairs, and then the converse of those theorems and postulate. So here is if a point is equidistant from the endpoints of a segment, then it lies on the perpendicular bisector of the segment. So they're both true. The perpendicular bisector theorem and also its converse is also true. This next section here talks about slope and equations of lines. So this is really a review. You've seen this in algebra last year. So let's just do a quick review on slope and the equations of a line. Remember that the slope, right, of a line is the ratio of rise over run. Okay, so we always memorize that, rise over run. So that's the ratio that we use for slope. Okay, so if we look at the segment here on the coordinate plane, and we can just draw a right triangle kind of connecting those 2 points. Okay, so in order to go from one point to the next, we have to move 1, 2, 3, 4, 5, 6, 7, 8. 8 units, 8 units to the right. So that's our run, right? And then we had to move 1, 2, 3, 4. We had to move 4 units up. That was our rise. Okay, so our rise is 4 and our run is 8. So that's rise over run, so 4 over 8. When we simplify that, we get 1 over 2. Okay, so that means the slope of this segment is a half, is 1 over 2. Now remember that we have 3 forms of the equation of a line. One is point slope form, the other one is slope intercept form, and the other one is standard form. The point slope form and the slope intercept form are the ones that you can visually see or directly see the slope. Remember that the slope is m, right? So point slope form, y minus y1 equals m times x minus x1. Slope intercept form is y equals mx plus b, right? Where m is the slope and b is the y-intercept. And the standard form is ax plus by equals c. Recall that parallel lines, okay? Recall that parallel lines are lines that never intersect. And parallel lines have the same slope, right? If they run side by side, they never intersect, which means they have the same rise over run. They have the same slope. In order for us to determine if lines are parallel, all you have to do is um, make sure your equation is either in point slope form or in slope intercept form, because those are the types of equations that you can directly see m, right? Directly see the slope. Then you have to just compare the slopes. And if they're the same, that means the lines are parallel. If the equation is in standard form, you have to manipulate it so that you switch it. I think the easiest is to switch it to y equals mx plus b form, which is the slope intercept form, and then you can compare the slopes. So let's look at this example right here. I have the first equation, y equals 2x plus 9. I know the slope here is 2. That's the number that's right in front of x. That's the coefficient of x, okay? That's 2. That's my slope. The other equation is in standard form, so I have to manipulate this, switch things around so I can write it as y equals mx plus b. The first thing I need to do here, I need to subtract the x term from both sides. So I subtract 2x and I subtract 2x. These two x's cancel out. I bring down the negative y equals. Now, I always want the x term in front, right? That's how y equals mx plus b. So I'm going to write the negative 2x first. Then I'll bring down the plus 5. Remember that the 5 and the negative 2x are not like terms, though they cannot be combined. I just list them separately. So after I write this, I don't want the y to be negative. It has to be positive. So I just divide everything by negative 1. I divide negative y by negative 1, negative 2x by negative 1, and 5 by negative 1. And then I get y equals 2x plus 5. And then now I just look for the slope. The slope is the coefficient of x. In this case, m equals 2. Because those two slopes are the same, that means these lines are parallel. Okay, so let's see how do we write the equation of parallel lines, okay? In this question, we want to write the equation of a line that is parallel to the line y equals x plus 5, and it goes through the point 3, comma 2. So we want to write this in point slope form. First thing you want to do is you want to identify the slope that you want, right? The slope of the line is 1 in this case here. The coefficient of x is 1, right? The slope is 1. Because I want a parallel line to that, the slope is going to be the same. It's also going to be 1. So I wrote my equation here in point slope form, the general form, right? Y equals y1, y minus y1 equals m times x minus x1. And then I start substituting. For the point here, x comma y, so I have 3 comma 2. So x is 3, y is 2. So I just substitute them here for y1 and x1. Y minus 2, which is my y1, equals the slope, which is 1, and in parentheses, x minus x1, which is 3. So I substitute that for 3 right there. And this is the equation in point slope form. We're ready to go. All right, let's take a look at perpendicular lines now. So perpendicular lines are lines that intersect to form a right angle. Remember, right angle, 90-degree angle. Perpendicular lines have opposite reciprocal slope. Remember, opposite, positive or negative, right? Negative is the opposite of positive. Positive is the opposite of negative, okay? And then reciprocal means when you flip the fraction, okay? So if I have a fraction 1 over 3, right? The reciprocal of that would be 3 over 1, okay? So these are reciprocal to each other. You just flip the numerator and the denominator, okay? All right. So now let's take a look at how we can find, how we can determine the slope of the line perpendicular to these following examples. So I have y equals 2/5 x minus 8. So the first thing I want to do is I want to find out what is the slope of this line. Okay, so this line has a slope of 2/5, okay? Positive 2/5, okay? So first, opposite, right? Opposite of positive is negative. So I have the negative. And then when I flip 2 over 5, I end up with 5 over 2, okay? So that's the opposite reciprocal slope. For this example, I have negative 1/5, okay? So opposite of negative is positive, and then reciprocal of 1/5 would be 5, right? Would be 5 over 1, okay? But then the 1 at the bottom, you just disregard, right? You take that away, and then you end up with a slope of 5, okay? So 5 is the opposite reciprocal of negative 1/5, okay? For the next one, we have a slope of negative 2, okay? So the opposite of negative is positive. The reciprocal of 2, now this is 2 over 1, right? Remember, you always have a 1 on the bottom. We just don't need to write it. So it's 2 over 1. So when we do the reciprocal, we end up with 1 over 2, okay? So 1/2 is the opposite reciprocal of negative 2. So this example asks us to determine if these two lines are perpendicular. So you're going to follow the same steps that we had above for parallel lines, okay? First, you want to identify the slope of the lines. The first line here is easy because it's in slope-intercept form, so we can see that the slope is 2/3, okay? The coefficient of x. So the slope here is 2/3. The next one is not in slope-intercept form, so we need to manipulate it. We need to move things around to write it in slope-intercept form. So the first thing we want to do here is you want to subtract the x term from both sides. So we subtract 2x, we subtract 2x, we end up with 3y equals negative 2x plus 4. Now we need to get rid of this 3, the coefficient here of y. So we divide every term by 3. We end up with y equals negative 2/3 x plus 4. So now, what is the slope of this line? So the slope of this line is negative 2/3. That's the coefficient of x. Okay. Now that I found the slope of both lines, I want to compare them. Okay. Are they opposites? Let's see. This one is positive. This one is negative. Yes, they're opposites. Now, are they the reciprocal of each other, right? Do we flip the fraction? So let's see. This is 2/3. This is also 2/3. So no, these are not reciprocal of each other. So that means that it's not perpendicular. So those two lines are not perpendicular. Now let's look at the next example. Now the next example, we're asked to write the equation of a line, okay? We want to write the equation of a line that is perpendicular to this line, y equals 3/4 x plus 1, and it goes through the point 1, comma 8. First thing I want to do, okay, let's see, what is the slope of this line? Okay, the slope of this line is 3/4, okay? That's the coefficient of x. That's the slope of this line. So if I want the perpendicular to that, I know that it has to be opposite reciprocal of 3/4. The opposite of 3/4 is negative because 3/4 is positive. And then the reciprocal of 3/4 is 4/3. So the slope that I want is negative 4/3. Okay? Now this is the slope I'm going to use in the equation right here in point slope form. I substitute 1 for x1 and 8 for y1. So y minus 8 equals the slope, which is negative 4/3. Be careful not to use the same slope because this is perpendicular. If it's perpendicular, we have to use the opposite reciprocal. So we put in negative 4/3 for m, parenthesis x minus 1, right? X was 1. Okay, now I distribute the fraction. I distribute the negative 4/3. I end up with y minus 8 equals negative 4/3 x plus 4/3. Okay. Now what I did here is I used a trick called clearing the fractions. Okay. If there are two ways to do this, you can clear the fractions, or you can just use the common denominator when you add the 8 to 4/3, okay, and then solve it that way. I like clearing the fractions because it makes things simpler, and then I remove all the denominators that way. So what I did here is I had the 3 for denominators, so I multiplied every single term of my equation by 3 because that was my denominator. So I end up with 3y minus 3 times 8 is 24 equals. Now negative 4/3 times 3, remember the 3's cancel out, so I end up with minus 4x. It looks like I made a mistake here. I will fix that in a minute. So here's minus 4x. Then when I multiply 4/3 times 3, remember the 3's cancel out, I end up with plus 4. Okay. All right. So now notice that I don't have any more denominators. I don't have any more fractions. So now I just add the 24 to both sides. So I end up with 3y equals negative 4x plus 28. Okay. I have to now get rid of this 3 that's in front of the y. Okay, so when I divide by 3, divide here by 3, and divide the 28 by 3. Okay, I end up with y equals negative 4/3 x plus 28/3. Okay, if you did it using the common denominator, you should get the same answer. Okay, your steps were different, Okay.